the double angle formulas are what we're working with today. It has a lot to do with the same kind of ideas as what we did with the sum and difference, about plugging things in. If I gave you guys something about sine A is 1/3 and A is an angle in the second quadrant, find the cosine of A. What do you guys have to draw to figure this out? Triangle, good. Now this time though, we are in the second quadrant, so make sure it looks like a bow tie. Hopefully you're using our properties of SOHCAHTOA, right? Opposite over hypotenuse, and make sure that the A, or the angle, is always towards the middle. So opposite would be 1, hypotenuse would be 3. Okay. Now, in the second quadrant, make sure sine is positive, right? Cosine is negative. How can we figure out the other side? Pythagorean theory. I don't think we have something special here. So we have 1 squared plus b squared equals 3 squared. This is going to give you guys 1 plus b squared equals 9. B minus 1. B should be radical 8. Yeah, we can reduce it. Good. What do you want to reduce it to? 4 and 2. Good. Will it become day? 2 radical 2. Love it. Good. Okay, great. I like how you reduced it. Now, if we wanted to do the cosine is the adjacent over the hypotenuse. So we could take the adjacent, 2 radical 2, and put it over the hypotenuse, which is 3. What else do we have to do here, though? Make it negative. Good job. But you're in the second quadrant, and cosine is negative. Yeah, forget all that little stuff. Good job. Right. So there's 2 ways that you guys are going to see double angles come up, right? Just like yesterday, you don't have to memorize any of this stuff. It's all given to you on your reference sheet, right? And it says like functions of the double angle on top. We have one for sine. We have 3 different options for cosine. We have 1 option for tan. So one way you guys see these is by using like a simplifying. You say, what could this simplify to? And we want to be on the lookout that whenever you guys have a 2 in front of your angle, so if it says like 2a, 2 theta, 2x, anything like that, we're going to have to use one of our double angle formulas. Okay. So if we look at our first little simplifying example, do we see any like double angle? Is it the top or the bottom? Good, just the top one. Nice. Right. This is not a double angle because it's not the angle that's being doubled, it's like the whole thing. Right, so the only one we're going to simplify is this top part, the double angle. So we want to look to see, right, which one of these do you guys think should you be using? The sine one, the sine 2a, right? So what we're going to have to do is think what it's equal to. Now, in our problem, though, we don't have a's, we have thetas. So that's the same thing as like what a is. So what we're going to do is take out the top, and we're going to sub in this part. So it's going to look like this. 2 sine, I'm going to put my theta in instead of the a, that's what we're working with. Then we have a cosine theta. On the bottom, this part's just going to stay the same. There was no double angle there, so it's just going to stay. Okay. The cosines are fine because it's multiplication. If it was addition or subtraction, we could have. So good, Frida. Exactly right. Once you guys have all your subbing, just look to simplify. The cosine theta, those are going to be gone. What else can cancel? Wait, the 2's. Oh, okay. Yep, just sine theta. You like that? The canceling? Always good when things go away.
But if not always going to do that, I assume.
Not as long as that easy, but, you know. Easy. So that was pretty nice. The good thing is when you guys get sine 2 theta or sine 2a, sine 2x, you got one option. It's a little bit tougher though when we deal with the cosines because you have 3 different possibilities. What we want to look for is maybe what way can help us cancel things out the most. Especially with multiple choice though, you might have to kind of try a couple options. Let's look at this one here. So this expression, we have cos squared theta minus cos 2 theta. All right. So just look to see if we can recognize, is there a double angle here? Yeah. Okay, not the squared, that's fine, it's this one, right here is the problem. Now, when we go to do our substitution, the cosine squared theta, we have a minus sign, we need to get rid of this and put the formula in its spot. But how do we decide which one to use? Well, we want to kind of use something that's going to help us cancel stuff out. So imagine this, you have a cosine squared here that's positive. Okay? Which one of these maybe will help us? Maybe that has something with a cosine squared to cancel it out. Yeah, this first one, good job. That one actually has the cosine squared in it. Okay? So it's going to probably help us maybe when we reduce some things.
So because the second option has a 2 in front of it, that's not as
good. Now, we might do the substitution, and it might not be an option for our multiple choice. So we might have to do a different one. Right? It's kind of a pain in the butt more than anything. And usually, what they do is they try to pick the one that's got the easiest substitution for you. Right? So let's put this thing in. Now we're going to sub in cos squared theta minus sine squared theta. So cos squared theta minus sine squared theta. You want to be really careful with this stuff. Notice, when I make a substitution, it might be easier for you to put parentheses around it so you remember some special things. What do we have to do with this minus sign? Distribute it through. Good job. So it's got to go to both things. Right? Or those of you guys who like copy, change, the same thing, like you're subtracting a quantity. Okay, so we have cosine squared theta minus cosine squared theta. And then what's going to happen with your sign though? Be positive. Good job. All right, nice. So now your cosine squared can cancel out, and we're left with just sine squared. Now you may have been able to pick another one, right? But you might have had to do like some additional tougher work, right? They should all get you to the same point eventually. Let's try this. All right. Plus cos 2x over sine 2x. All right. Yeah, good job, Carly. You guys have 2 double angles. Oh, bro. You got both of these you have to get rid of. So, you only have one option for the sine one. So let's just fill in this stuff. I know I have to have a 1 plus. My sine 2x, the only option for that one is my sine. So one angle up. And we're going to have to use this one. So 2 sine x goes back. 2 sine x cos x.
So you heard any side that you see, you're going to substitute the top one?
Yep, that's it. I know, so much
There's
nicer.
only the cosine one.
Exactly, then you have 3 options. That's the one you kind of need to think a little bit about.
Does it matter if we use theta and x's?
No, I'm just using x's because there were x's in my original. Okay, so like your multiple choice will have the x in it. So that's one reason. All right, so how are we going to decide which cos 2x to use? Well, let's look and see what we have in this. We have 2 sine x cos x. Right, cos 2 theta. Do we have anything that might help us here? Okay, kind of none of them really look the same, do they?
No, the ones that have, like, that you kind of want to have like cosine squared.
Yeah. Oh, all right. Well, let's see. Well, we have a 1, right? Maybe was anything in our formulas have a minus 1 that maybe things would cancel out? Yeah, let's try the second one. Remember, you want stuff to go away, so let's try to use the second one because it has that minus 1, and maybe some things will work out nicely. Let's see, 2 cosine squared. We have plus 2 cosine squared theta, that was minus 1, right? Okay, now if you have a plus sign, do you have to do copy, change? No, all right. So if it's just because I did a substitution, I put it in parentheses, but if you don't have a subtraction sign, it's not really changing anything. Okay, good. So let's see, Frida, I love what you're saying here. The ones cancel out? Like it? Okay, good. 2 theta. Great job. And the cosine, Scarlett? Good job.
But then you're left with
1 on the top. All right, great. So we have a cos x over sine x. What is that the same as? Cotan. Good job. Very nice. But you want to look to see, like, always look at how you cancel things. That's the easiest way to do it. Now, there are other ways. If you guys don't pick the easiest one, you can have a lot more
So
stuff.
no matter what one you pick, if it's like a cosine and goes with it,
it should work out. Okay. It just depends how difficult the simplifying is going to get. You know, but you might have to use like Pythagorean identity substitution, which will be wrong. So if you guys just always look to see like what you have, and then kind of look to see if you have the opposite sign of the same thing in the formula, that's probably the one you want to choose. Then it'll go away. So that's the first way you guys would see this as like simplifying. The other way, you guys basically just did this yesterday, it just looks a little bit different. So, for your first one, okay, if they give you guys something you know about cosine theta, 7 over 25. Find cosine 2 theta. Well, if you guys are using cosine 2 theta, let's see what we got here. You have 3 options for your formulas, right? You have all 3 of these. If you only knew that they gave you guys that cosine of theta was 7 over 25, which one of these 3 only uses cosine in it? The second one. So because they gave us only something about cosine, we're going to use the one that has only cosine in it. Right? Because they already gave it to you guys. You already know that part. So we do our substitution. It'll be 2 cos squared theta times 1. Right. Now, since we knew what cos theta is, right, this becomes 2. If we wanted to do cosine squared, what do you guys think we'd have to do this 7 over 25? Square it. Good. Where's the minus 1? We're basically like plugging the fraction into the formula, just like yesterday. Okay. Just be careful with your pen now. Right, 7 over 25, we're going to square that, times it by 2, and then subtract 1. So just watch out for your stuff. If anybody has like those special options, you get alpha window. Yeah. Yeah, alpha, if you do, let's for a second. If you do alpha y equals, you get this little fraction key, which is kind of cool. So if you wanted to put this in at once, I think it'll read it if you use that. So if you did 2 first, so 2, and then alpha y equals, and you can actually, oh, jump, and tab it over, and just forget that. 2, we do a constant, alpha y equals 7 over 25. Square that, and then minus 1. I think that's the same thing, hopefully. The same. Great. So that'll help with your pen dash, just nice little shortcut. Alpha y equals. So negative 527 over 625. I mean, that's fine though, because if you have something you're squaring it, it's going to be pretty big, right? Okay, weird stuff. Yeah, like look at they're pretty big. Alright, so they give you guys something about sine theta is 5 over 13. What is the value of sine 2 theta? Well, this is a nice one, because like Abby was saying, if it's sine 2 theta, you got one option. This is great. So it has to be 2 sine theta cosine theta. That's what this equals from your formula sheet. You guys know where I'm getting this from?
Yeah.
Like from the front part? Okay. So let's fill in what we know. We got a 2 here. Do I know what sine theta is? 5 over 13, right? Oh no though, I don't know what cosine theta is. Yes. Oh wow, good. You guys are getting really good at this. Okay. I heard lots of good things. Frida, what you just did, fantastic. If you can do this in your head, go for it. Who said draw a triangle? That's great. That's good. Okay. Anytime we're missing stuff with trig values, right? Draw yourself a picture. It says an acute angle, so that means less than 90. Okay? And you're dealing with sine opposite over hypotenuse. Right, so here's your theta, the opposite's 5, hypotenuse is 13, and that was great for you. You knew what was the bottom one. 12, good. So now if you wanted the cosine of this, cosine adjacent over hypotenuse, so 12 over 13. Okay. So from here, just like yesterday, you guys are just actually like multiplying this all out. If you want to use that new fancy key. Okay. Okay, let's see. So let's see. Well, 5, 13, times 10. Oh gosh. I always mess this up. I'm not used to all the tabs. Hopefully that.
Just gotta delete the front. Yeah, it should be
Just
good.
delete them.
So do you have a what tab on that one?
I know, you'd think it would work.
Just make sure.
Alright, we're gonna go for it. Is that what you guys
Yeah.
got? Okay, good. One phony over one is How are you guys doing so far with like filling them in? Not too bad, hopefully. Alright, let's see if you guys can try out. Why don't you try out example 6? Okay, notice they give you guys, you're in quadrant 2 this time. Oh, this is tough. It should not be a 3, 4, 5 triangle. I'd be really careful. Freeze, that would be the big number. You know how you were like doing it? Because usually you see 3, 4, like, oh, it's got to be 5. But,
Because it doesn't say.
well, where's the hypotenuse? 4, right? So, yes, you got to use Pythagorean theorem here a little bit.
I'm not gonna do it.
See, at least, I think we're getting this radical 7. Okay. What are you guys putting in for your sine theta?
First radical.
Good, radical 7 over 4, nice. Oh, this looks good. Let's look at that theta. Is your radical 7 over 4, should that be positive or negative in that second quadrant? Positive, good. Now, if you guys have this substitution, that's like where most of us are right now, watch out for this word, exact value. It's been coming up quite a bit. Can your calculator handle a radical? No. So that exact value, you do not want to use your calculator for that radical part. When you guys are multiplying your fractions, make sure it's top, top, bottom, bottom. So on this part, we have 2 times a negative 3 should give you negative 6. Then you have your radical 7. over 16. Good, and we can reduce it. Nice. What number goes into 6 and 16? 2. Right. So 2 goes into negative 6. We got negative 3. And then 2 goes into 16 8 times. Right, and that would be an exact value, right, with the radicals going there. It comes up quite a bit. All right. Right. Your homework is a worksheet. It's kind of the same. It's kind of the same idea as like yesterday's. I did it the same way as your notes. Go ahead and take the problem.